Hello, let's start with the 8th lecture. Today, we're going to learn about files. In the previous lectures, we learned that variables are boxes or spaces that hold values. This space exists within the computer's physical device called RAM. Variables and values are stored in RAM while the program is running. However, data in RAM is erased when the computer is turned off or programs are closed. To preserve data after rebooting the computer or exiting the program, the data must be saved to a non-volatile storage device, such as a hard disk drive, USB drive, or solid-state drive. Data can be stored in a name state on non-volatile storage. The name location is what we call a file. So, what is file I/O? I/O refers to input and output. To put it simply, reading or writing a file is called file I/O. There are many different types of data. For example, there are various types of data such as text and images. Today, we will focus on reading and writing text files with Python. A file can be opened using the open function. When the open function receives the location of a certain file as an argument, it returns the object of the file existing at the location. You can think of the term object as a group of methods and data. The file object does not contain all the data of the file, but provides functions that can manipulate the file. The open function receives the location of the file as a string argument and returns an object of this file. The open function has an optional parameter called mode, and the default value of this mode is R. To open a file in R mode means to read the contents of the file. If you pass W as an argument to the mode parameter, you can write the file instead of reading it. We will learn more about them later. If you want to close a file object, just call close method. You can also use the keyword with instead of a method close. The with keyword is mainly used when dealing with file objects. For example, the with keyword opens a certain file with the open function, stores the file object in a variable existing at the location of my file shown on the slide, and lets the file object be open while the code block below it is executed. Then it automatically closes the file when the code block ends. First, let's learn how to write something to a file. First, open the file using the open function. In this case, the mode is specified as W. When you open a file in W mode, if any file already exists in the file location passed as an argument, this file is overwritten and a new file is created. And you can write new text into it by calling the write method of the file object. And when writing to the file is completed, just call the close method. If you run the code, you will see that the example.txt file is in a folder with your Python scripts. You can check it in File Explorer of your operating system, or you can check this file in the Explorer window in Visual Studio Code. If you open the file, you can see that there are strings written to the file through the write method. If an existing file is reopened in writing mode, a new string is written to the file object, and when the close method is called, the file is overwritten and the previous contents are lost. Append mode A can be used when you want to continue writing to a file while preserving the original content. When opening a file, set the mode argument to A. After that, when we call the write method, we can append the new text to the text of the file. Let's implement the Python program that creates a file called numbers.txt that contains numbers from 1 to 100. There must be a space between each number, and the numbers that are multiples of 10 must be written on a new line. First, open the file. To open in write mode, pass W to the mode parameter. Then, loop through the numbers from 1 to 100 using a for statement. If the value of I is a multiple of 10, write a number and a new line character \n to the file. Otherwise, write a number and a space character. When the loop ends, close the file. If you open the text file, you can see that the file is written as expected. Now, let's learn how to read files. First, let's open the example.txt file we created earlier. You can read a file by passing R as an argument to the open function. By calling the file object's method readLine, we can read the text of the file line by line. There are several ways to read a file line by line. For example, you can print each line of a file by simply iterating over the file object as shown in the slide. The readLines method of a file object returns all lines in the file as elements of a list. For example, if you run the following code, you can see that a list containing each line of text is printed. Write a program that reads the numbers.txt file you created earlier and prints it to the screen. However, try printing all the text on one line. You are probably trying to implement this program using the readLines function. Let's take a look at the following program. First, create the file object myFile. After that, all lines of the file are read and stored in line list. Then create a string called allNumbers. Then, the string of each line existing in line list is appended to all numbers. At the end of the iteration, the program prints all numbers. However, there is one problem. Running the code doesn't print all the text in one line. This is because when each line is read using the readLines function, a new line character is appended to the text of each line. To solve this problem, when concatenating each line of text into the allNumbers string, we can concatenate all strings except for the last character of each element by using slicing. Let's look at the read method that reads all characters at once. The read method returns all text in the text file as a single string. Even if there are multiple lines of text, this text is returned as a single string rather than a list. Of course, since all lines are returned as a single string, the string contains new line characters. Let's look at the code on the slide. The code receives all text from the file example.txt and saves to a variable text content. And if you print this variable and the type of this variable, you can check that the read method returns a string. So far, we have only learned to implement programs that read and write files in the directory where the Python file exists. However, it is also possible to open files that exist in other folders. When opening a file through the open function, by passing the absolute file path as an argument, we can open a file that exists in another directory. There are two types of file paths. An absolute file path is an absolute location on your computer where a file exists. For example, a file existing on a certain drive is saved in a certain location on the drive, and specifying all of these paths can make an absolute file path. Relative file path refers to the relative expression of the path to access the file from the folder where the current program is executed. For example, as shown in the slide, assume a folder called My Folder exists in the same folder as the Python program file, and the file called readfiles.txt exists in that folder. When the Python program opens readfiles.txt that exists in My Folder, you can access it by expressing the path as shown on the screen. When opening a file using the open function, sometimes the following log is printed when trying to open a non-English text file, and the file cannot be opened. This problem occurs because you're reading a Unicode text file. Unicode is a standard for reading and writing various languages in computers. Unicode allows us to read and store multiple languages on our computer. In the past, different countries had different ways of expressing characters. For example, in some countries, there were no standards or rules for representing the languages of other countries. As a result, many countries were unable to utilize their computers to process files made in other countries or in other languages. Moreover, sometimes it was impossible to print other languages to screen with the computer. To solve this problem, standardization takes place. One of these standards is Unicode. Many countries started using the standard to read other languages. And by using Unicode, people can store their own language in a format that can be read by other countries and foreigners as well. For example, a rule was created to store the uppercase letter A of the English alphabet as the number 65 when stored on the computer. And a rule was created so that the uppercase Cyrillic letter V is stored in the computer as the value 1032. So when reading a file on a computer, if the file complies with the Unicode standard, the value 65 in the file is recognized as the character A. The process of storing and processing a certain character in correspondence with a certain number is called encoding. Computers are not paper, so we cannot write and store various characters with a pen. However, a computer can electrically express and store any number through an electrical signal. For example, the number 1 can be represented by applying a voltage to one tiny space in RAM. And there's a lot of very small physical space in RAM. Eventually, the computer can store and process large amount of number by using RAM. And we can set a rule that any character is represented by a number. Eventually, encoding enabled computers to process text as well as numbers by converting them to numbers. Unicode is one of the encoding methods. Among the various encoding methods, Unicode is the most widely used encoding method worldwide. There are various versions of Unicode, among which the UTF-8 version is widely used. Let's see how to fix the error we saw earlier. For example, if a file is created using Unicode encoding, when we open this file using the open function, we just need to pass an argument UTF-8 to the encoding parameter. This allows us to read even files written in Unicode. Now, let's solve some problems. Assume that we want to implement a program that stores the names and birthdays of classmates on the computer. Write a program that continuously takes the user's name and birthday and saves them into a file called birthdays.txt. If the user enters save instead of name, the program should be terminated after saving the data entered so far in the file. In the text file, save the information in the format shown below the slide. For example, we can implement the program as shown in the slide. Open the text file in write mode. First, create a variable called save and initialize it to false. And the loop should be written in a way that the loop ends when the user inputs the string save. Receive a name string from the user and store it in a variable called name. If the string is save, the variable named save is set to true. When save becomes true, the repetition condition, not save, becomes false, and the repetition is terminated. In other cases, the date of birth is continuously input from the user. The program then writes the name and birthday to the file all at once, and the loop continues. If you run the program, you can see that the program works well. This time, let's investigate what season the friends were born in. Assuming that there is data in the birthdays.txt created earlier, try implementing a program that reads the information of friends from the birthdays.txt file and prints the season in which each friend was born in order. Calling the string.split method with the space character as an argument returns a list by splitting the string based on whitespace. First, assuming a birthdays.txt file has already been created, read the file and read each line of the file. By traversing the file object with the for loop, we can read each line. Save each line as a list in string list split by whitespace. This will break each line into a string of name and a string of birthday, and they will be stored in the string list variable. Therefore, the string at index 0 becomes the name, and the string at index 1 becomes the birthday. Assign these values to a variable named name and a variable named bday respectively. We need to classify each friend's birthday by birth month. In the program we created earlier, the birthday is stored as a 4-digit number consisting of month and day. So we can think of the first two characters of the birthday string as the month of birth. So we can use the slicing technique to extract the first two characters of the string bday. However, since bday is a string type, we should cast the string to a number using the int function and store this numeric information in a variable called month. And the value of month is checked in the conditional statement. If the person was born between March and May, the string spring is printed. If the person was born between June and August, the string summer is printed. If the person was born between September and November, the string autumn is printed. In other cases, it is between December and February, so winter is printed. If you run the program, you can check that the program runs as expected. This is end of today's lecture. Next time, we'll learn about classes. Thank you.